Hello everyone, this is Shubham Chaudhary and I welcome you again in the new video of our YouTube channel. Today we will discuss this LeetCode hard problem which was asked on 25th of February. So the problem is greatest common divisor traversal. So here they have given a zero indexed integer array nums and we are allowed to traverse between its indices. So we can traverse between indices index I and index j and I not equal to j if and only if GCD of nums of I and nums of j is greater than 1, where GCD is the greatest common divisor. Then the task is to determine if for every pair of indices I and j in nums where I is less than j, then there exists a sequence of traversals that can take us from I to j, and we will return true if it is possible to traverse between all such pairs of indices or false otherwise. So let's take a look at the first example. Here the input nums array is 236, so the output will be true because in this example there are three possible pairs of indices 0 1 0 2 and 1 2. These are indices. So to go from the index 0 to index 1, we can use the sequence of traversals 0 to 1, where we move from index 0 to index 2 because GCD of nums of 0 comma nums of 2 equals to GCD of 2 comma 6 equals to 2, which is greater than 1, and then move from index 2 to index 1 because GCD of nums of 2 and nums of 1, that is GCD of 6 comma 3 is equals to 3, which is greater than 1. So to go from index 0 to index 2, we can just go directly because GCD is equals to 2 greater than 1. Likewise, to go from index 1 to index 2, we can just go directly because GCD of these is greater than 1. So that's why we will return true. Here in example 2, 395, it is false because no sequence of traversals can take us from index 0 to index 2 in this example. So we will return false. And here there is another example. So here there are 6 possible pairs of indices to traverse between, that are 0 to 1, 0 to 2, 0 to 3, then 1 to 2, 1 to 3 and 2 to 3. A valid sequence of traversal exists for each pair, so we will return true. So let's see the approach for this problem. So first of all, we will create two unordered maps, prime to index and index to prime, and then to map each prime factor to its corresponding indices and vice versa. So we are creating two unordered maps here to map each prime factor to its corresponding indices and vice versa. So after that, we will populate the maps by iterating through each number in the input array nums and factorizing each number to its prime factors. Then for each prime factor, we will update the mappings in both maps accordingly. And after that, we will implement a depth first search function DFS to traverse the graph formed by the prime factors and their corresponding indices. Now we will start DFS from index 0 and mark visited indices and prime factors. So during DFS traversal, we will recursively visit the indices connected to the current index via prime factors. So after DFS, we will check if all indices have been visited, and if not, we will return false, otherwise we will return true. So that is the approach we will follow here. So let's code for the solution. Before that, if you are new to the channel, hit the like button and subscribe for more content. So let's discuss. Here we will create two unordered maps first, that are prime to index and index to prime. So here we will create two unordered maps. So key will be the int and type int, and our value will be type vector. prime to index and index to prime. Then in the can traverse all pairs function, we will define some logic here. So we will first of all iterate. There is a vector int num, so we will iterate through by the for loop from I equals to 0 to I less than nums dot size and I plus plus. Then we will initialize a temp variable and pass it nums of I. Then again a for loop from int j equals to 2 to j into j less than equal to nums of I. So we are just going into the squares of that number up to nums of I j plus plus. We will check here a condition that if temp per modulo j equals to 0, if it is true, then we will push back I to prime to index. So prime to index of jth position, we will push back I here, and again we will push back j in index to prime position for vector index to prime of I. We will push back j, and after this, while temp modulo j equals to 0, we will do temp divide equal to j. So we will divide temp to by j, and after this, if condition, we will check another condition that we will check if temp greater than 1 or not. I think we will do this. We will implement this condition outside of this for loop. So if temp greater than 1, then we will do what? Prime to index of temp dot push back of I, and index to prime of I dot push back temp. So after this, in the main bool function, we will do what? We will create a vector in visited index, and we will give the size as nums dot size and value as 0 to every element. Then we will create an unordered map of int comma bool and call it as visited prime. Then we will call a DFS function which we will create now, pass it as 0, then visited index comma visited prime. Now what is this DFS function? Let's define it here. So we will define DFS function here. So DFS, it will return void. It will accept parameters int index, then vector int ampersand visited index, then an unordered map int comma bool underscore visited prime. So let's check spelling. Okay, visited prime. And what we will do here? We will check first of all if visited of index equals to true or not. Then return. Then next step we will do. First of all, we are checking if the visited index is equal to true or not. If it is true, then we will return, and after that we will call this visited index of index equals to true. And then we will use for loop for iterating and using auto ampersand prime in index to prime. We are calling index to prime for iterating through it of index. And what we will do here, we will check if visited of prime is equals to true or not, and if it is true, then we will simply continue. Else we will do what? We will visited prime. We will update this visited prime value to true, and for auto ampersand index, we are iterating here in prime to index of prime, and we will check here a condition that if visited of index 1 equals to true. If it is true, then simply continue. Else we will call DFS again, index 1 visited index and visited prime. That's what the visited function is, sorry, DFS function is for. And after the completing DFS function here, so we will iterate through for loop from int I equals to 0 I less than visited index dot size I plus x, and we will again check a condition that if visited index of I equals to false, if it is false, we will return false, else we will return true. So this is I think I am missing something. This return statement should be here. So this is the right statement. Let's check if it is running or not. Use of undeclared identifier visited. So index visited index. Here we need to add visited index. Yeah, the code ran successfully. So this is the code for the solution. If you are getting any doubts, or if you are confused, or if you want more clarity, you can also refer this approach parallelly with the code uh, 1-2 times. Then we will get the solution. Let's submit the solution for checking the hidden test cases. Yeah, the code ran successfully. So talking about the time complexity, here it will be big O of n into root m, because we are iterating through nums dot size, and here we are iterating to j square. On the duration of j square means root m. So n root m is the time complexity, and talking about the space complexity, it will be big O of n plus n. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. And stay tuned for upcoming LeetCode problem of the day videos and exciting month stack web development projects. Thank you.